Good morning, good afternoon, and good evening, everyone. I'm Rob Meyer. I run outbound product management here at GridGain. We're going to get started in a few seconds, but first I just wanted to make sure everybody knows their way around the GoToWebinar control panel and knows how to ask questions and also is not having issues. So if you are having issues, please feel free to go into the questions section and tell us. But in the meantime, if you look at the upper right-hand side, you should be able to see a little hand signal. And in fact, I am trying to find it right now, but if you can go raise your hand, that would be great. I see people being attentive, hands raised, and no one yet. Oh, there we go. We got some hands going. Thank you. I appreciate it. So during the webinar, you're going to be on mute. Don't worry. There is a chat question. There's a question section in the a little bit down in the GoToWebinar panel. You can ask questions, and during the webinar, I will be answering some of them. I am going to be saving the hardest questions for our speaker, who is Greg Stacknick, who runs inbound product management for cloud. And today's webinar is all about cloud. It's really about taking Ignite into production in the cloud. And Greg has probably seen more than anybody else inside the company around the good, the bad, and the ugly around deploying Ignite in the cloud, both in public and private cloud. So with that, we will eventually turn it over to Greg. If you're not familiar with GridGain, you may know that we contributed the original code to Apache Ignite, and we continue to be a leading contributor. So a lot of the feedback that you give us, we actually roll back into the Apache Ignite project. We also have commercially supported versions. We started releasing back in March the community edition, which is free. It is open source. But it's something we harden. We get to do more testing on it. We get to patch it more frequently because it's the release process is a lot faster than what we can do with the Apache Ignite project. It's just the way the project works. So you've got a free, hardened, more recently patched version that you can download on gridgain.com. And then there are other features we've added to help take Ignite into production a little bit more easily into the Enterprise and Ultimate editions. So feel free to ask us questions anytime about that. Greg is going to probably go into some of those when he's explaining some of the good, the bad, and the ugly. But with that, let me turn it over to Greg Stacknick. Greg, it's all yours.
Cool. Thank you very much, Rob. And greetings, everyone. Thank you for taking the time to join us today. So this is, like Rob said, it's basically a best practices discussion about how we take Ignite and GridGain applications into a cloud. And I'm going to be focusing a little bit more on the public clouds because it tends to be where we get a lot of questions. So, you know, if you've attended some of the previous webinars, there's a series that we've been producing around moving Ignite into production. And this is just kind of another step along the way. So as we get into this presentation, the agenda we'll be following is we're going to introduce Ignite and GridGain for those that are new to the technology. We'll define some terms around cloud so that we have kind of a common set of vocabulary as we're kind of discussing the pluses and minuses of different features of different cloud providers. We'll look at how people are deploying to the cloud. And then we'll get into the best practices, and that's really the meat of this presentation is, you know, looking at some of the challenges that customers have had and how we can, you know, think about better ways of setting up our deployments and maintaining our applications. But to get started, let's just think about quickly what is Ignite and what is GridGain. So Ignite is a memory-centric data platform. It's used to build fast and scalable and resilient solutions. It's used to provide speed and scale to new and existing data-centric applications. And GridGain is the kind of more commercial offering that's built on top of Ignite. If you're not familiar with Ignite, it's an Apache project. It's the fourth most active Apache project in the Apache Foundation. And some of the key features of Ignite and GridGain are things like distributed memory-centric storage. So, being able to store giant data sets in memory, spread out across multiple nodes in a cluster. Co-located compute, so being able to take the computations or business logic and running those directly in the instances where our data resides. So eliminating common bottlenecks like disk I/O and networking. There's a number of ways that we can access data that we populate into our grid. One is via key value APIs. Another is via distributed SQL. And a lot of people that come into Ignite and GridGain are coming from a strong kind of SQL-based background. They might be coming from like a relational database experience. And so being able to do SQL against your data sets in the grid is something that's very useful. Ignite also supports, and GridGain also support ACID transactions. And how do we access the grid? Well, we have multiple client technologies. So depending on your language of preference, we give you the ability to build integrations or query the data through things like languages like Java, .NET, C++, PHP, as well as REST for more API-driven communication. And the GridGain platform caters to a wide range of use cases, including core banking services, real-time product pricing, risk management, analytics, machine learning. And then built on top of Ignite, GridGain provides some additional enterprise features. This includes, but is not limited to, the ability to perform more advanced monitoring and through management tools like GridGain or Visor or Web Console. We provide security and auditing framework. GridGain also gives some tools to help manage data across multiple clusters through a feature called data center replication. We'll be talking about that as in part of the best practices. And GridGain also adds the ability to do persistence to support things like backup and recovery and snapshots and features like that. So as we've been kind of working with customers over the past few years, we found that about, maybe 2 or 3 years ago, more and more customers have been wanting to move their Ignite or GridGain workloads off of your traditional bare metal on-premise type installation and move them into different types of configurations. They want to take their grids and move them into a cloud, or they want to look at how they can take those applications and deploy them via containers. And so we had to take a hard look at how we had built GridGain and Ignite and started to kind of re-architect in order to support cloud native development more properly. And so as we've been kind of making that journey through a different architecture, we also joined the Cloud Native Computing Foundation, the Linux Foundation, gotten more active in those communities, so that as we've been kind of improving the frameworks to support both containerization or cloud-based deployment, we're taking feedback from the community, getting more active, and then being able to kind of give you the best practices. And so a lot of the best practices that we're going to talk about in this talk are coming both from kind of our experience as we've been looking at supporting cloud native development better, as well as just the feedback we've gotten from customers as they've already been taking that journey. So got to think about what is the cloud really? Cloud is a really overloaded term, especially as it's been used even more in kind of consumer electronics. You can go to anyone really, anyone that has a mobile phone really, and ask them what is a cloud, and everyone has some sort of opinion. Even to a non-technical person, they might tell you that, well, the cloud is where I store my pictures, or it's where I get my voicemails. You might ask someone that works in an office setting, and they may say, well, the cloud is how we collaborate on documents, or how we work together on presentations, or how we collaborate on spreadsheets or something like that. Some companies that are doing more sales or marketing oriented activities may say, well, the cloud is how we manage our pipeline or predict our revenue or how we monitor our marketing campaigns. But maybe to most people on this call that's joining this webinar, the cloud is something else, right? It's how we deploy our applications. It's infrastructure that we use to deploy and scale and secure and manage bespoke applications. And ultimately, really at the end of the day, what is the cloud? Well, it's infrastructure that we don't necessarily have full control over. And that has some implications. So we took a poll of different cloud providers and look at how they talk about cloud. And it provides some interesting inputs. So we looked at Salesforce and we went through some of their white papers and best practice documents about what is the cloud and how do you use it. And so we kind of produced a bit of a word cloud, and some of the things that we were able to pull from that is, it talks about, the cost, like capital expenditure. It talks about flexibility and where you can work. It talks about collaborating on documents. They talk about, they're environmentally friendly because you're not setting up your own local data center. You're working on shared resources. And so, some of the things that we took away from this is that for a company like Salesforce, the way they describe cloud often really describes how their users work with their product, right? It's a SaaS application where the access to the underlying infrastructure is much more obscure, and you're really working with the application itself and in its hosted environment. Contrast that with the way a different cloud provider like Bluemix talks about cloud. For them, they talk about storage options, they talk about machine shapes, they talk about data security, still talk about collaboration and remote access and things like that. But they're describing cloud in probably a way that's more familiar to us as application developers, right? We're describing it more in terms of the qualities of infrastructure and how we access that infrastructure, and configuration options with that infrastructure. So as we're talking about cloud, for the purpose of this talk, we're going to be talking about it really at the infrastructure level and as a set of services that we use to deploy bespoke applications and some of the configuration options that public clouds can give us to be more flexible. And so let's look at a few qualities of a public cloud. And maybe as we're defining this vocabulary, then that makes it easier for us to describe some best practices. So one thing we think about when we're talking about public clouds is the ability to scale. And if you think about how we may work in a traditional environment, in an on-prem data center, our scalability is limited by our physical hardware. Right? We have a set of hardware that has a set capacity, and if we want to scale to support a bigger load, well, we generally have to buy more hardware. We need to set it up in our data center. We need to hire staff to maintain that hardware and patch it and make sure that it's working properly. And that's very different than the way we work with a public cloud like Amazon or Azure or Google Cloud. What we're looking for in a public cloud is the ability to scale on demand. And that gives us some flexibility both in terms of how our applications run and our cost structure, because we can really just pay for what we use. So elastic scalability gives us the ability to add or remove, at least in the case of a distributed system, gives us the ability to add, remove nodes as our load changes, and we can add capacity in minutes without having to buy new hardware. And we can plan our infrastructure changes or our capacity changes, based around expected load. For example, if we're like a credit card company or an online retailer, there are specific times of the year where we're having sales, like a Black Friday or a Cyber Monday, where we know we're going to get a spike in traffic, and we can very easily plan that increase in capacity. But the elasticity of cloud infrastructure also allows us to react to unplanned changes where maybe we have some instability or just a sudden spike for no reason. And there's a lot of options in our public cloud providers that allow us to react and keep our applications up and running properly. And we'll talk about some of those configurations in the best practices. Another quality of public clouds is flexibility, and that actually is kind of falls into a few different ways. So one is where our applications are deployed. We can deploy our applications into data centers wherever the public cloud provider has a presence. And with the major cloud providers like Amazon and Azure, that basically gives us flexibility to really deploy anywhere. And that's much more powerful than when we're working with physical data centers that are our own, where our locations have physical limitations based on the buildings that we are building and where we can get them built. And so location is an important thing when we're considering flexibility. Flexibility around machine specs is also something to consider. We may have one set of applications that are very compute-centric, in which case we may want to provision machine shapes that are more CPU intensive, have more cores dedicated, whereas we may have another set of applications that are more data-centric, and CPU cores may not be as important, but a huge memory allocation is something that we may want to work on or may want to pick. So that flexibility provisioning is also something that is a little more unique or valuable when we're working with public cloud providers. It also can make it easier when we're rolling out new versions, because we can set up a new availability zone or deploy into a new data center, deploy a new application, and then divert traffic into that new version of the application and then turn off the old infrastructure. Something to think about, though, when we're working with public clouds is that, well, this really is not our data center. And there are pluses and minuses to that. So, the obvious plus is we don't have to maintain it ourselves. But with that loss of control, we also have less control over how we can configure and what we can get access to. And so there's some things to think about. Like, for example, how are you doing backups? Is there a strategy that you need to think about when your data is in the cloud? Are you doing a hybrid cloud deployment? So meaning, is some of your data still on-prem? Like maybe the source of truth for your data is in an on-prem data center in a database somewhere, but your applications are being hosted up in the cloud. How are you securing these applications? Because you don't have full access or full control over the infrastructure, there's definitely some considerations to make when you're thinking about how we secure the applications hosted in a public cloud. And so, there's a lot of things to think about, and because of that lack of control. And one way that we can kind of alleviate or allay some of those concerns is by coming up with our first best practice, which is tools. And so, when you have full control over hardware, you can maybe get kind of lazy because you can SSH into the machine and restart servers, and you have full control over everything. But in a public cloud, you have less access. And so the best way we found, and that our customers have found in working with these public clouds, is to come up with a standard set of tools and to automate everything as much as possible. When working with VM-based deployment, we try and make our VM provisioning as repeatable and as possible. And there are tools such as configuration management tools like Chef, Puppet, and Ansible that can help us set up VMs in a way that we don't have to do as much manual configuration. Anytime we have to think about manually configuring VMs, there's always a risk of introducing human error instability into those VMs. In terms of other types of tools, monitoring is something that can really help us work with our applications deployed to public clouds. And there's kind of a decision that we need to make around monitoring and tools. Do we want to use kind of more vendor agnostic tools for monitoring, such as, Kibana or Prometheus or Splunk for log analytics? Or do we want to consider some of the vendor-specific tools, such as Amazon's CloudWatch or Microsoft Azure Monitor? And the decisions that we make around the tool set often kind of depends on whether we need to be able to flexibly deploy across multiple cloud providers. If we know that we're going to be an Amazon shop, then there's really less harm in building our integration and our tooling around Amazon's services. But if we consider that we may need to deploy across multiple clouds, like to Amazon, and maybe have some of our application or have a backup deploying into Azure or Google, then coming up with a tool set that is more vendor agnostic might be better. And then there's another set of tooling as well, and that really is depends on how we're doing deployment, whether we're doing VM-based deployment or whether we're doing container-based deployment. And a lot of our customers that are deploying to clouds are using container-based deployment through Docker. So Docker is a standard unit of software that packages up our code and its dependencies, and it makes deployment of our applications more repeatable and predictable because we don't need to manually configure each instance or container. It's defined by metadata. And Ignite and GridGain work really well in Docker-based deployment. And we even have starting images posted to Docker Hub so that you can kind of get started very quickly to spin up a GridGain node and clusters, or Ignite node and clusters. And kind of going along with our containers is how we manage containers or how we orchestrate containers. And while it's not the standard yet, but it's quickly becoming the de facto standard, Kubernetes is our way of managing containerized applications. So for in-memory computing, you can deploy the grid and the rest of the application resources. Kubernetes can then help manage the containers. It has some basic administrative operations like restart, startup, shutdown, scaling, things like that. And another benefit of deploying an in-memory data grid or Ignite via Kubernetes and containers is it makes it more repeatable and consistent, and it's vendor agnostic. Now, another option when we're doing deployment and using tools in a cloud is actually to work with just a more platform or SaaS type option, which is GridGain Cloud. So GridGain Cloud is a fully managed and hosted version of Apache Ignite. It gives you a set of tools, and it will basically give you a way to spin up a set of caches that you can then load your data into. And GridGain will take care of backup recovery, making sure that the data stays up and running. It's currently deployed in Amazon-based data centers, but it's just an option if you wanted to very quickly get running up in a cloud. The rest of our recommendations, though, are really focused around the assumption that you're going to be deploying to a cloud and you're going to really be maintaining everything yourself. So another deployment option, we can go with probably the one that you're mostly considering, which is Amazon. And Amazon has a lot of options. It can get a little confusing because a lot of those options are kind of just thrown at you right when you when you create your account. There are multiple ways that we can deploy instances. If we're doing a VM-based approach, we're going to be looking at EC2. If we're doing container-based deployment of our data grid, we may choose to deploy our manage our containers through the ECS, which is a container service. It sort of predates Kubernetes. If we're choosing Kubernetes as our orchestration engine for our Docker containers, we can set up our own Kubernetes in Amazon, or we can use the hosted Kubernetes service. There are different ways that we reserve our instances. They can be on-demand instances, they can be spot instances, we can have them dedicated. There are many different shapes and sizes. There are different underlying chipsets that we can choose from, Intel or ARM. There are many networking, different ways that we can configure networking and firewalls and security between our instances. The point here is that there's a lot of different configuration options, and it can be a little overwhelming in the beginning. And so the rest of our best practices are going to help kind of give you some recommendations on different machine shapes, different machine sizes, some configurations in Amazon, so that maybe we have fewer options than it makes it easier to get started. Azure also has just about the same amount of options for deployment, but they kind of make it a little bit, they guide you to your destination or guide you to the configuration a little bit better. It's basically, are you doing VM-based deployment or container-based deployment? And then they give you more options depending on the path that you choose. Like virtual machine scale sets is a container service that is specific to Azure as opposed to their hosted Kubernetes service. We also looked at Oracle Cloud and Google Cloud, and we will provide some recommendations and configurations for those as well. So for best practice number 2, memory. So you're going to be using with a memory-centric technology like Ignite, your memory choices can be pretty important. And the choices that you make depend on the type of use cases that you're going to be employing. So it depends on what you're doing. If you're using, generally you want to pick the bigger memory configurations. Most of the big memory configurations in Amazon and Azure have enough CPU power to go along with whatever the calculations or queries are that you're going to be doing against the data. Generally from Amazon, we have found that 5R and R5D, where D is the D configuration is good if you're doing persistence. Those have performed pretty well. X1 and Z1 instances have also been pretty good. They have they're big enough so that you can actually have more nodes in your cluster and not spend as much money. The high memory configurations that are like 12 terabytes in one box are probably overkill for a lot of the Ignite use cases that you may be using. For Azure, the E instances are better, E32, E64. The G series with its dedicated hardware is also quite good. On the Google side, we generally recommend you try the high memory machine types like N1 High Mem 64, which has about 416 gigabytes of RAM. Oracle, you have fewer options. I would stay away from OCI Classic. That's the older technology from Oracle Cloud. I would stick with OCI. They change the name from time to time. I believe it's called Oracle Cloud Infrastructure Gen 2 or Bare Metal or something like that. The tools that you can use with the newer version of OCI are more like what you would get out of like an AWS. Another thing to think about is replication. So replication is basically how we can add resilience to our data. So the idea behind replication is that we have a cluster of nodes and we are taking a subset of that data and copying it across our nodes so that if an individual node goes down, we still have copies of that data in other nodes. Once we bring that node back up, then we repopulate the data back on that node and we have no data loss. And so if we're doing replication, then we might be able to get away with more smaller nodes or VM sizes when we're deploying our in-memory grid. Another thing that a useful utility when we're getting started with kind of figuring out the sizing and the pricing of these instances, both in Amazon and Azure, is to look at the Ignite sizing calculator, and have a link to that here. So another thing to think about around best practices is disk storage. And the recommendations here also kind of depend on the features of Ignite or GridGain that you're using. Are you using Ignite and GridGain as an in-memory database and are you using persistence? Are you taking advantage of backups and snapshots in order to set up high availability or point-in-time recovery? Or is your use of disk storage more for logging? And so kind of depending on the features that you're using, you may want to pick different storage options. Generally, at least on the Amazon side, block storage or EBS is what you'll want to go with. And you generally want to pick the fastest block storage available. And so that is the SSD-based block storage, like provisioned IOPS SSD IO1. We found that actually works pretty well. There's another type of storage that you can consider, which is the instant storage volume. So in your EC2 instance, you have an attached storage to that EC2. And one thing to think about is that instant storage volumes have a risk of data loss. If you have data that's being stored locally in your instant storage volume attached to your EC2 instance, and you reboot that EC2 instance, the data does get preserved and it comes back. But if for some reason that EC2 instance goes down or it's stopped, the data is wiped. So that's something, if you're not using replication, you probably do not want to just rely on instant storage volumes to back up your data for your GridGain, your in-memory data grid. In which case, we generally just recommend that you go with block storage, because block storage is like a network attachment, so it persists, it stays even after an EC2 instance possibly goes down or leaves. From an Azure perspective, the standard or the premium SSDs are generally preferred over like the spinning disks. And if you're doing Kubernetes-based deployments, then we recommend that you look at stateful sets. And stateful sets, the recommendations on the types of storage that you use with stateful sets, it's the same even if you're doing a VM-based deployment. So if you're using Kubernetes stateful sets on Amazon, we still recommend that you use SSDs, and the same with Azure, either the standard or premium SSDs. Another thing to think about is if you're doing VM-based deployment, we could consider using images. And so in Amazon, an image is called an AMI or an Amazon machine image. In Azure, it's called a managed image. In Google Cloud, I believe it's just called an image. But the idea is that we want to be able to have repeatable configurations that are consistent. And so if you're using VM-based deployment, you may want to set up a set of images for your Ignite instances that you can then spin up on demand. You can set up multiple images. You can have a golden image that you then apply additional configuration management to. But the point is that you do not want to be manually configuring those images every time you need to spin up a node. Because the idea around in-memory computing is that we have a cluster and nodes are entering and leaving the cluster regularly. And so if we can automate how those nodes are being provisioned in that cluster, it just makes things work much more much easier and less manual operations required. So anytime that we can automate in our cloud instances, the easier it is for working with in-memory data computing and distributed systems. All right, so another thing to think about is performance. So when deploying to a public cloud, your application could be deployed to a shared resource. So if you need to do real-time workloads or high performance, you may want to consider getting a reserved instance. A reserved instance is generally reserved on a block of time or over a specific period of time, and it reduces the risk of you ending up with like a noisy neighbor situation. Spot instances can be fine if you're just using them for kind of short-term usage. For example, maybe you need a burst of capacity because you have an unexpected load that you need to scale out for in order to maintain application performance, then spot instances are fine. But we don't recommend that you use spot instances exclusively because it's a little less predictable in the types of performance that you will get out of them. Let's see, so Amazon and Azure, as well as Google Cloud, all have tools to help with auto scaling. So that can help if you define rules around, capacity, around CPU usage, memory usage, storage usage, then you can have some of their automated tools spin up additional instances for you. Kubernetes also has an auto scaler feature that you can take advantage of when working with a distributed system like Ignite or GridGain. Let's see, one thing to also think about specific to Ignite and GridGain when working with these features is that it doesn't support auto baseline updates. So after adding a new node to your GridGain cluster, you will need to update your baseline topology by one of our utilities like Control-SH or something else like that. And then another thing to think about is licensing. So if you're working with GridGain, obviously licensing is not an issue with Ignite, but if you're working with GridGain, it is a CPU-based license, so you'll need to consider that if you're doing a lot of auto scaling and bursting and things like that. All right, so another thing to think about, best practices around security. And so remember, this is someone else's data center, so we do need to make sure that we take steps to make sure our applications and our data is not accidentally exposed in a way that we had not planned. So there are a number of different tools that public cloud providers give us to secure our applications. There are different ways of doing encryption. You can do disk encryption so that confidential data is protected in case of a breach. There could be potential performance issues when you're doing disk encryption if you're having to access the disk and decrypt it regularly. Ignite and GridGain have multiple security options built into the framework itself that you can take advantage of. You can also enable security in between the nodes through things like TLS and SSL. There may be a slight performance hit when you're adding in security in between the nodes because the nodes are very chatty. They are communicating among each other, passing data back and forth. One thing to think about is when you're securing your grid, some customers have tried to block all ports with a firewall in their cloud. And you need to remember that the nodes need to be able to communicate together in the grid. So you don't necessarily want to close off all ports so that nodes can't communicate together. So one thing to maybe consider would be to set up a virtual network for the grid and then secure entry and exit into that virtual network so that you can still have communication among the nodes. Okay, so another thing to think about is data location. And one important question when thinking about data location in a public cloud is is all of your data hosted entirely in the cloud, or are you doing kind of a hybrid deployment where maybe your application and your data grid is in the cloud, but you are still maintaining an on-premise data source, like a database or something like that? A lot of our customers are doing kind of like a hybrid deployment where the applications are in the cloud, the data grid or the in-memory or the data grid or the in-memory database is as close to the application as possible, so it's also in the cloud. But then we have our data sources still on the ground or in their own data center. And so there are some important questions that we need to ask if we're working in a hybrid cloud environment. One question is around consistency. So is it important to have immediate consistency between our application in the data grid and the data source? And the other question that we need to ask is, do we have exclusive access to the data, to the on-prem data source, or is it being updated? Is that data being written to or updated by other applications that we don't have control over? And those two questions will kind of describe how we maintain consistency and how we maintain synchronization. If immediate consistency isn't important and we aren't doing real-time processing, we can consider doing a batch-based system. And when doing batch-based updates, we can either do like a full data extraction, or we can just update the deltas back to our on-premise environment. Obviously, just updating deltas would be a little bit cheaper because there's less bandwidth, but it's more complicated because we need to actually calculate the deltas. If your applications have exclusive access to the data such that you're not worried about collisions, if you need immediate consistency, you might want to consider an in-memory data grid that has a read-write pattern with a synchronization layer between your grid and the data source. Another thing to think about is if you don't have exclusive control over the applications connecting to the data, and you have a risk of data collisions, or if you don't need immediate consistency, you might want to consider a change data capture with your in-memory data grid using like a read-only pattern. Now, those types of recommendations are not necessarily cloud specific. They're really more specific to how you're deploying your in-memory data grid or specific implementations of your in-memory data grid. And I'm just providing very high level kind of recommendations on that. I would highly recommend that you check out Rob's best practices webinar called Adding Speed and Scale to Existing Applications. He goes into much more depth. He provides architectural diagrams. He gives you much more details on how you actually set that up. But overall, just using an in-memory data grid will always be cheaper than your more traditional approach to data access, because you're loading the data into memory in the cloud such that every read is not going back across a network into your on-prem environment and consuming more and more bandwidth. So another thing to think about is how are we going to, what if we wanted to migrate data, either across a cluster within our same availability zone or into a different data center, or take advantage of different data location options that public clouds give us. GridGain has a feature that makes that very easy called data center replication. And it kind of works like this. So say our application or say our data is in one data center, and in this case, let's say it's in one region, and we want to replicate that data into a different region. Well, we set up another cluster with our nodes, and then we use the data replication feature to define our senders. They will send the cache data over to our receiver cluster, and then we can basically use automated tools to monitor the progress. Tools like GridGain's Web Console or Visor will allow us to watch the data as it is migrating between the two clusters, and we can see that if the data is being checked, we can look at how successful it's been, things like that. And then if the goal was just to migrate from one data center to another, once the data has completely been migrated, then we can take down the original cluster. Another option is if we wanted to maintain data across multiple regions, then we can keep our data flowing between the hubs and the centers. And there's a lot of configuration options that you can set up for data center replication. I would refer you to the GridGain documentation for additional options there, for additional information. So what have we learned? So the cloud is different than the way we work with on-premise deployments. We have a lot of access to a lot of power, but there's a lot of options, and sometimes it's confusing to know how we get started. So some of the best practices that we covered in this session are coming up with a consistent set of tools and thinking about whether we want to go with vendor specific, the cloud specific tools, which give us a bit of a vendor lock-in versus coming up with an agnostic set of tools. And the real decision point is whether we're doing VM-based deployment versus container-based deployment, and that really kind of describes which set of tools we use from after that. We looked at different memory sizing options, and it's often really depends on how what aspects of Ignite you're using. Are you doing more of a compute grid, CPU intensive deployment, or are you using Ignite more as a data grid to get as much data into memory as possible? We also discussed disk storage options and different configurations, both in Azure and AWS. Generally, we want to work with SSDs and block storage as it's more permanent. We talked about for VM-based deployments, the value of custom images, because that gives us more repeatability and more predictability in the way that we deploy and set up our nodes. We looked at performance options and we talked about kind of resources, whether they are in a shared resource, the value of setting up resources ahead of time versus using spot instances. We talked about security and how we secure our applications in between nodes and the application in general in a cloud. And then we talked about some synchronization issues in data, and then how we can perform replication across data centers. So for more information about GridGain and Ignite, I really recommend that you check out some of our other webinars. And those can be found in the resources section of gridgain.com. Also, if you're interested in traveling to the Bay Area, our IMCS Summit is coming up a little bit later this year. That's a great opportunity to talk to other users and exchange ideas and get, talk directly with the developers of Ignite and GridGain and some of the other in-memory solutions. Also recommend that you check out white papers that are in our resources section. Those will give you some more in-depth information about configurations and best practices. Our videos are available in the resources as well. And if you want to get access to a 30-day trial, just go to gridgain.com/download. So let's open it up for questions. Rob, how are we doing with questions here in the chat?
All right, we have a few. I should mention on the GridGain downloads, you can download Community Edition forever for free. So feel free to go download that as well. That's basically hardened Ignite. So There was one basic question I thought at the very beginning, which was appropriate. It's probably what everybody has to answer at some point. Have you seen any differences between the different public clouds? Which one seems to be better for Ignite? Or what have been some of the issues in some of the clouds with Ignite that you've seen?
Well, from our experience, the majority of our end users have been running on basically either Amazon or Azure. Probably 80% of the customers I've talked to have been on Amazon. And in terms of difficulties, some of it just has to do with the configurations of which EC2 instances or which kind of memory options they're picking, and whether they're giving themselves too much compute or not enough RAM. And so that was kind of why I wanted to provide some of those kind of recommendations on shapes in, I think it was best practice number 2.
Okay. Yeah, I've seen some more GCP than you have, I guess, more Google Cloud as well. So in general, we've seen, I think, on the order of 10,000 nodes. And this was a while back. This was a year or two ago, already running Ignite on those various nodes. But that literally was something like 2 years ago. There have been quite a few deployments of open source Ignite. On the GridGain side, it's a little bit of a different mix. But Ignite overall, there does seem to be a lot of Google Cloud as well. But we haven't seen any. I haven't seen any major differences either. I haven't seen anything that holds people back one way or the other. There were some of the issues you were talking about with Amazon and disk, saving disk as images go down or crash or change. How does the persistence work? And things with SSDs where they don't necessarily get saved in some instances, and so that was a little trick. But otherwise, haven't seen any real difference or any real reason beyond the pricing of how the pricing works in each cloud and what other applications you're running with Ignite. Meaning, sometimes it's the other applications that are the big deciding factor, not Ignite, for which cloud you choose. And so that's more often than not what we see, that they've chosen a particular cloud, and then they just need to make sure that Ignite works well with that cloud vendor. Another question here was more around monitoring tools. How would you set up monitoring? How would you think about the monitoring tools that the cloud vendors have versus other monitoring for setting up the environment?
So I think there's kind of multiple layers of monitoring. So in terms of monitoring the core infrastructure, say we're doing a VM-based, well, even regardless of whether we're doing a VM-based or container-based deployment of Ignite into, say, an Amazon or an Azure, they provide kind of the coarse-grained monitoring to monitor the instances themselves. And CloudWatch works fine. Azure Monitor works fine. If you're going down like a very vendor-specific route. Another option is to use kind of vendor-agnostic tools like a Prometheus or an Elk Stack. But then another thing to think about is really monitoring more for the in-memory data grid itself, not just the instance, but the features, like how is data replication working? What are the important metrics that you want to monitor across your nodes, like heap usage, RAM usage, CPU usage, garbage collection policy, things like that. And in which case then you probably want to use something that is a set of monitoring tools that is really specific to Ignite and GridGain, something like our own tools like Visor, which is kind of better for more on-prem workloads, or Web Console, which you can set up more as a service. And so if you were deploying into, say, an Amazon or an Azure, you can deploy Web Console in those same environments. Web Console then uses an agent to connect to your grid, and then it will collect metrics on your grid so that you can check to see how well your nodes are performing. What are the versions of Ignite or GridGain that are deployed? Do you need to do any kind of upgrade to newer versions of Ignite, or do you need to set up like snapshot and backup policies, things like that? So when working with the grid itself, strongly recommend trying out our own tools like Web Console, and Web Console is available to configure. We have you can use it, via direct install or via Docker-based deployment. We have documentation on it.
All right. Quick question here. Are there steps to set up an Ignite cluster in Azure? I thought there were.
Yes, I believe, I have to check. I believe we have some base images available on the App Store. I'll have to check though. But otherwise, if you're doing a container-based deployment on Azure, you can pull one of our base images off of Docker Hub, and that will get you started really quickly. Otherwise, you can deploy Ignite into a VM just as you would any other.
Yep. So there is in Azure Marketplace, there is an instance. It may make more sense. I think, Greg, it seems to make more sense to take a standard Docker image or build your own, and then there isn't any particular difference between Azure and others on setting up the cluster, I think. But once you're using Docker, but this brings up the other question, which is around Kubernetes. Any recommendations when you're using Kubernetes or transitioning into Kubernetes for Kubernetes newbies? What are some of the gotchas, the things you have to watch out for or plan ahead for?
That's a good question. So yeah, we have some best practice articles, and I think it's best I'll just attach some of those to these slides from when we publish them. And then let's see, one best practice around Kubernetes is if you're using persistence, you should look at stateful sets. And otherwise, we are planning to publish some configurations for Kubernetes to our GitHub examples in the next month. So we'll upload some Helm charts, so some sample configurations for you to get started.
Yeah. Okay. The